Good afternoon, everyone. Today I'll be talking on motion for Jamb physics revision. So, the types of motion, the first type of motion we have is the random motion. And from the word random, we know that this kind of motion is an irregular one. That when particles move up and down without any bearing. An example is a smoke particle, dust in air. So any movement that is irregular without no direction is called a random motion. Then the second type of motion that we have is the translational motion. We also have the rotational motion and then the oscillatory or the vibratory motion. So these are the four type of motion that we have: the random motion, translational motion, rotational motion, then oscillatory or vibratory motion. An example of random motion is smoke particle in the air, the dust in air. Example of translational motion is a car moving from one place to another. An example is maybe a car moving from Lagos to Abuja or Lagos to Abeokuta. While rotational motion, an example is our fan, the movement of fan and also the rotation of the heart about its own axis. And then the example of oscillatory or vibration motion is the simple pendulum, the beating of the heart, the motion of a child's swing. That in the oscillatory or vibration motion, there is a periodic manner. So particles move to and fro in a regular periodic manner. So don't forget we have four types of motion: the random motion, the translational motion, rotational motion, and then the oscillatory or vibratory motion. So I will now be talking on linear motion. Actually, something about motion is that motion is very wide, extremely wide. And just like a revision class, I would be doing a lot of compression. For example, then in this video, I will just be talking on linear motion and then the equations of motion. And then in the next video, I will talk on the distance time graph, displacement time graph, and the velocity time graph because I do not want that video to be too long. Let's start with the first. These are some of the things that we must know under linear motion. The first one is speed. Speed is the rate at which a body covers a distance. Speed is the rate at which a body covers a distance. And speed is a scalar quantity. If we say something is a scalar quantity, what it means is that it has only magnitude or numerical value but no direction. While uniform speed is when an object covered equal distances in equal interval of time. So when an object covers equal distances in equal interval of time, that object is said to have a uniform speed. Then we also have velocity. That velocity is the rate of change of displacement. And something about velocity is that velocity is a vector quantity. That means it has both magnitude and direction. And the basic thing between speed, difference between speed and velocity is that speed is a scalar quantity, while velocity is a vector quantity. So speed and velocity have the same unit. That is, they are either in meter per seconds or in kilometer per hour. And there are some special cases like that can have them in kilometer per minute, kilometer per seconds. But the most common one is meter per seconds and the kilometer per hour. And sometimes they are used interchangeably. There are some questions like that the speed and velocity will be used interchangeably. Then the next thing we should know under linear motion, rather, I'm sorry, is our acceleration. The acceleration is just defined as the rate of change of velocity. Acceleration is equal to final velocity minus initial velocity over time. Acceleration is final velocity minus initial velocity over time. And the unit of acceleration is meter per second square. So don't let us forget the unit of speed meter per seconds, the unit of velocity meter per seconds, but the unit of acceleration is in meter per second square. So let's move forward. Then we now have the equations of motion. And these four equations that you are seeing on your screen are extremely important. In fact, yeah, so this equation that you are seeing on your screen are extremely important. These four equations you must know it compulsorily. In fact, I will even advise you by now is that you pause that video, you pause this video and you assimilate this equation because it is extremely important. The first one is V is equal to U plus AT. We also have S is equal to UT plus half AT square. We have V square is equal to U square plus 2AS. Then we also have S is equal to half U plus V times T. These equations are extremely important. And our S implies the distance covered when U is the initial velocity, V is the final velocity, A is the acceleration, and T is the time taken. So please and please, that equation once again is extremely important. We can't say that we are talking on motion and you will know the equations of motion. So let's move forward. So these are some of the hints that we must know on the equations of motion. We must first know that when a body moves or accelerates from rest, its initial velocity is equal to zero. When a body moves or accelerates from rest, its initial velocity is equal to zero. When a body stops or comes to rest, its final velocity is equal to zero. While when the body velocity is constant, that is when the body has a constant velocity, the acceleration is zero. So don't forget, whenever you see something, a body starts from rest, know that initial velocity is zero. And when brakes are applied or a body comes to rest or stop, the final velocity is zero. And if the velocity is constant, our acceleration is equal to zero. So now let's look at some of the examples that a body starts from rest and accelerates uniformly at 5 meters per second square until it attains a velocity of 25 meters per second. Calculate the time taken to attain this velocity. So the first thing is that we'll write that our parameters. Our U is zero. And the reason why our U is zero is because the body is starting from rest. I mentioned it earlier that when the body is starting from rest, the initial velocity is zero. So from that question, our acceleration is 5. Then the final velocity is 25 meters per second. And then we are now asked to find the time taken. So after we are through with our writing of parameters, the next thing is which equation are we going to use? And then from the parameters that we have, we know that we are going to use the first equation. We know that we are going to use the first equation, which is V is equal to U plus AT. So these are the equations that we have on the solutions. So let's look at the question again. This is the question, and there's the solution. The time taken to attain it is 5 seconds. Then the second question, a car take off from rest and covers a distance of 80 meters on a straight road in 10 seconds. Calculate the magnitude of its acceleration. So we write out our parameter first. Our initial velocity, since the car is starting from rest, our initial velocity will be 0. The distance covered, the distance that we're given is 80 meters in 10 seconds. Then we are now asked to find the acceleration. So we use the second equation, and that's s is equal to ut plus half at square. And that's the final, the acceleration is 1.6 meter per second square. This is the equation, and that's the acceleration. So don't forget, the once you know the equations, the four equations, you are good to go. So the third question, that the car moving with a speed of 90 kilometers per hour was brought to rest by the application of brake in 10 seconds. How far did the car travels? So the first thing that we have to do is that we have to convert kilometer per hour to meter per seconds. And the easiest way, whenever you want to convert from kilometer per hour to meter per seconds, is to divide by 3.6. And when you want to convert from meter per seconds to kilometer per hour, you multiply by 3.6. This is extremely important. Some people might be saying that, why am I using a very fast method? If you are doing Jamb, one of the things that you must take note is time. And for those that will still be doing physics, chemistry, and mathematics, you know that you must not joke with time. So whenever you want to do the conversion, do the fast method so that you won't waste your time. So when we divide 90 divided by 3.6, it will give us 25 meters per seconds. So these are our parameters. And then we use the fourth equation. This is the fourth equation that we use. And then we slot in what we are supposed to slot it, and the distance covered is 125 meters. So look at example 4. A motorbike moving at a velocity of 3 kilometers per hour accelerating uniformly for 10 seconds at a rate of 0.1 meter per second. Calculate the distance is traveled. So we can see also here that when we divide 3 kilometer, 3 divided by 3.6, it will give us 0.83. I use the fast method. There's another log method, but there's another long method which it is possible that we'll still talk about later. And then I slot in my parameters, and well, from that parameter we'll know that we are going to use the second equation, and that's the answer. The answer is 13.3 meter. The distance covered is 13.3 meter. So this is an assignment that I want us to do, and please, when we are through with this assignment, let us write the answer in the comment section. Just write your answer in the comment section, and then we'll give out the solution to this assignment. It's very simple. Once you just look at the example that we were given, you will be able to do the assignment. So by the grace of God, our next physics class will be on distance time graph, displacement time graph, and the velocity time graph. I've said before that motion is very wide, and I don't want this video to be too long. So we'll see you next class. Bye bye.